Welcome, friends. It is office hour. We're going to talk a little bit about databases. Databases are going to be things that in the wild in industry, you will be dealing with almost always. Now, the reality is you're probably not going to be managing or setting up databases. That's just usually, unless you're like the one developer at a startup. There's usually somebody that does that, whether it is a like database engineer. If you're at like a higher one, that's people's entire job is just to handle the databases, handle what we call data pipelines. So when you're ingesting data, if you're sending it to the cloud, what that process and that it's called a payload. So what that looks like, what sort of data you're receiving, especially if you're working with things that are IoT, which means Internet of Things. So anything that's sending it, you think of like a smart TV or you think of like a smart light bulb. Those are all called IoT. Smart fridges, all of that stuff. So if they're sending some data, you're ingesting that data, right? And the way you ingest it is you ingest it right into however you do in the cloud, usually like an S3 bucket if you're using AWS or into different sort of storage. And the way it used to work is you would get some data in, whoa, sweet, in the cloud, right? And you would get all this data, but storing data used to be really expensive because storage was expensive, right? And I guess even before that, let's just kind of go to the history of it. Is you would back in the day, you would have some your own company. You would have some sort of way that they could store some data, right? And they would keep it in. It's called on premise, meaning that you've got servers, you've got racks, you've got networks. You are in control. And the way that you can sort of think about it is this is going to be like a cloud computing slash databases. Just a heads up there. We can sort of think about it is you're in control of everything, right? These servers have to run. Let's just pretend that this is your server. They've got to run 24/7 because your site and your site reliability is being hosted on this, meaning that this is connected and being shown. This is how you show something on the internet, right? Is you host it on a server that then connects, and whenever Google searches, finds that and gets that. Now, with that, this is what's called being on premise, or you might hear it as on prem, meaning that you are handling everything. And there's a lot of costs that come with this. You are handling, if the operating system or if there's any sort of issue or bug within your server, you're having your people having to deal with that, right? Or little nuancy things that you don't really think about. What about a generator, right? If your internet or your like internet reliability, but then also what if your power goes out in your area and it's out for the next 5 days, right? Do you have enough power to keep your servers up and running, especially if customers are paying, or you're a emergency service, right? Or something of the nature. You have to make sure that you're prepared for everything. And so that can be really expensive. It's called CapEx. It's called capital expenditure. So let me do another one. And that is, what does it take? CapITL expenditure. So basically, what does it take in order to run this? And this can get, oh, I do not like the new whiteboard. This can get expensive, honestly. What? Sorry, guys. This new whiteboard is tripping me out. Okay, I'm going to lose my mind. CapEx is capital expenditure. Maybe I have to go like that. There we go. So what does it cost for you to be able to do this, right? To be able to run this. Now the cloud comes in and they say, hey, that is expensive. You have to hire somebody to do this. You're in control. You have to do not only do you have to, it's called standing it up, right? Not only do you have to have all of the server, if it gets older and there's new technology, you're in charge of replacing it. You're in charge of getting new stuff. You're in charge of maintaining the operating system. You're in charge of cybersecurity. Or is it protected? Can people hack in and steal your stuff? It becomes a lot, right? And so then Amazon really is one of the big ones. Oracle was really kind of the first one. But then Amazon comes in and they go, hey, we will do it for you. And this is going to be our cloud. right? They said, hey, we'll do it for you. You don't have to worry about it. You don't have to do anything. Just connect to us and we will handle everything. We'll make sure that the um, systems are up and running. We'll make sure that the operating system's up and running. We'll take care of the cybersecurity. We'll make sure that it's up and running. There's enough power. It's always connected. Your stuff's backed up. We can make sure all of that's happening. Another big cost that you would never really think about with computing is heat, right? Because you have these computers and servers running, and especially if you have a big room, it gets really, really hot. If they overheat, then they can melt, right? And so you've got to pump in AC all the time. And so there's a lot of cost for a company. And so Amazon comes in and says, hey, we'll do all that for you, right? You just pay us this fee. And companies love it because you can, to an extent, right? Depends on your usage, but you can kind of predict what you're going to pay, right? Instead of you having to have these assets that are depreciating, instead of you having these assets that you got to maintain, you've got to handle, you just know, well, what does it take for me to operate, right? And so with that, it's called OpEx, which is operational expenditure. So companies really love this. Operational expenditure. So companies really love this because it's really easy to say, hey, here's our financial sheet. Here's what we're anticipating our cloud's going to cost versus, oh no, one of our servers goes down. We've got to replace that. That's $3,000. How do we depreciate that and amortize it over time? How do we do all that and bring in all the accountants and all that stuff, right? You don't have to worry about it, right? You can plug and play. And what's nice about cloud computing as well is, let's say that your company's growing really, really fast and you need more server space, you need more data, you need more of a database, more memory. Well, you've got to, if you're using your CapEx or what would be called on-premise. On-premise. Oh, I messed up. What would be called our on-premise? Not a great UI. If that happens, well, you're now limited by the amount of time that it takes in order for you to buy a brand new, to buy some sort of server. It doesn't have to be new, but use, make sure it's updated, make sure you update the operating system and you get it up and running. Versus the cloud, if you need more, you can just click a button or say, yep, I want more. And then it'll give you more space, right? Or more computational power or more whatever you need. On the other end of that, let's say you're on premise and you get really popular really, really fast. And then all of a sudden, you don't get as popular. I don't know if you guys, I can't even remember the name of it. There was a really popular app that people would just go and sit. It was kind of like a podcast, but it was kind of like a room and you could just go sit in it and people could talk. Clubhouse. Thank you, Chris. Yes, Clubhouse is what I'm thinking of. It got really popular really fast. Everybody was doing it. And it was like exclusive. You had to have an invite. And so they had to, if they were on premise, they'd have to scale up really, really fast. They'd have to get more servers. They'd have to get everything up and running. Well, now Clubhouse is not as popular, right? And so I don't know if their usage is the same. I would assume that it's not. I would assume that it was kind of like this golden goose and then kind of went down. But with the cloud, you can just scale back, right? And say, okay, well, I'm not using as much anymore. Let me scale this back. Versus if you invested all of the money and you hired on people to maintain this, now you're just sitting on product that like maybe you don't need this much storage, maybe you don't need this much of this many network engineers because your usage is low, but there's nothing you can do. You just have to turn around and sell it. Maybe it's not selling as much, you lose money versus cloud computing. Really, it's like turning on a faucet, right? If you need more computational power, you need more storage, you need more everything, you can just turn it on. And if you don't, then you can like turn it off and say, actually, I need less, right? Like take this from me. And then you just get charged for whatever you use, which is usage, right? This will all come in, I promise. So that is the idea on like on-premise or on the cloud. Now you can use hybrid cloud architectures, meaning that the three big ones are AWS, which is Amazon. You've got Azure, which is Microsoft. And obviously there's other ones too, but there's Azure. And then it's called GCP, which is Google. And that just is Google Google Cloud Provider is what GCP stands for. So those are your main ones. And some of them, AWS is the leader in market share, meaning more people and more companies are with AWS. Then it goes Azure. It's not close. I think last statistic I saw for 2022 was like Amazon, like 44% of the market share. Azure was around 22%. And GCP was like in the teens, if not like low, like 11%. And so Amazon's absolutely the leader. It's not the best experience for a developer. It's kind of complicated and a little bit challenging, but that's why we make you host on AWS, is because oftentimes you're going to go to companies that have AWS or using AWS. So if you have any sort of familiarity with AWS, it is really, really good. Now, obviously, with ChatGPT and AI moving, Azure got a little bit of a bump, but Amazon is still, I mean, I was at the AWS conference in November and it was amazing. It was way too many people. It was like overwhelming for sure. But on their books, if they didn't sell another, I was listening to a podcast on this. This is where I got it. They didn't tout this at the conference, but if they didn't sell another contract with AWS, they had $100 billion on the books of business that's going to happen. Like AWS carries Amazon as a whole, like as the parent company. AWS carries them financially. They're insane. Like the size of AWS is wild. And so with that, they've got some costs. They've got some things associated. There was an interesting article a couple of years ago where, again, cooling is a big deal, right? And Google was actually putting servers in the ocean and at the bottom of the ocean, which, whatever conspiracy of, interesting concept. But putting it at the bottom of the ocean because the water would cool that, right? It was obviously encased, but they used the cold water to be this like natural coolant. So it was just giving off heat and then the water would cool it. I'm not saying that Google is the reason of climate change or the oceans heating up, though I probably don't know that it helped. But those are the three main clouds and sort of the reasons why you would move from on-premise to cloud. Now, you can have a hybrid where maybe something is really, really, really important and you need to keep that with you. Then you would have you can have an approach where some of the stuff is on premise that you handle. So like Facebook, you can assume Facebook uses like lots of on premise stuff, but then also they use cloud computing, right? So you can have a hybrid of both. So it's not just one or the other, but these are really where cloud computing and on premise kind of differ. Is really the big words you're going to hear are CapEx and OpEx. Capital expenditure is, again, it's not advantageous often for companies because you've got to buy and invest a whole bunch of product and then you have to amortize that over time and depreciate it. Versus if you're a startup, you're saying, oh, cool, I have $1,000 every month that I'm going to give to the cloud. I know that's easy. I don't have to spend $20,000 on product, hire somebody to handle it. I just have to have a dev that knows a little bit about cloud computing to get that up and running, and we're good to go. Any questions on cloud computing? I'll show you where that sort of fits in to this, but any questions on that?
Will it be needed for black belt?
Yes, you will have to host on AWS in order to get a black belt.
Is it similar than what we did to Python?
Yep, same sort of thing. You're going to use, it's called an EC2. Okay. Amazon's not at all clever with their names. So EC2 is Elastic Cloud Computing. And so it's just E and then two C's, cloud computing. S3 is, it stands for like three S's. It's like something storage, simple storage. I can't remember what S3 stands for. But Amazon's like naming conventions are just basically acronyms for whatever it means. But yeah, you will have to host it on an EC2 instance. So that way I can go and visualize and see that.
Got it. Thank you.
Yeah, of course. But yeah, it's the same thing as Python. Same sort of tools that you're going to be using, just the operation will be different because you're going to be handling different databases and you have two different products that you need to put on there. Any other questions on cloud computing, on-premise versus in the cloud? Cool. There you go. If you ever want to learn about the cloud, at least now you have a little bit of a head start. No matter what, if you're studying for cloud practitioner or AZ900, they're going to talk about CapEx and OpEx. That's like the main thing about the cloud. Or one
So
of the
are there any AWS courses that maybe you might recommend?
Yeah, there is a guy on Udemy, Steven. Let me look it up on my other screen because I have their stuff. It's really good. Let's see. Oh my gosh. I can definitely give that to you. Give me 1 second.
It's Steven Marek, Ultimate AWS
I think
Certified.
that's it. Yeah. Yep.
Yeah, it's
Steven-
$20. So
Yeah, one thing to always know is Udemy is always on sale. So never ever pay. I almost made that mistake. And I panicked and I was like, "Oh no, I got to spend $150 on this course I could have got for $12." No. Udemy is always on sale. If you go back and it's like, "Oh, it is not on sale now." Literally wait a day and then it will go on sale. That's just how it always goes. So never, ever, 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 ever pay full price for Udemy. The prices
And
have
it's like it's crazy sale, like it's like 80% off.
yeah, they're always that. They're always, always, always that. And yeah, Nandor is right. You will have two different accounts that will show different prices. It's called dynamic marketing. So based off of depends on what you're looking at, what you're doing. So yeah, think about that. No, not a bad way to cheat the system. And oftentimes there's things on LinkedIn that'll give you like free day stuff. But like mine right now is saying like on sale from $13.99. A new world of learning, 2 days left. And then in 2 days, maybe for 1 day, it'll be full price, and then I'll go back to cheap. So but yeah, Stefan may let me see there. I wanna copy. So here is just this is the developer associate, but it does all of them. So I'll put this in the chat for you.
Yeah, I see that he has several. He has like a cloud practitioner, developer associate, and architect associate.
Yeah. So cloud practitioner is your base one. So that is Azure it's called an AZ900. That's like your entry level. That's where if I were you guys, I would say start there. If you wanted to go into the cloud stuff to understand it, just because I think it's a great thing. Like I would say that the first thing you should do is do that. You guys have a week off after this program before you go to next stack. I would even just say in that week off, go learn, go take it. Like still try to learn. There's a lot going on, so I'm not expecting you to learn it all in that week, but you should definitely at least start familiarizing yourself with that stuff because the cloud is going to be part of your job. That is a fact. You'll need to be able to spin something up or get a script that, or build a quick tool that the marketing team can use, but they're not going to want to download Python or download MERN and download all these packages and run it because they don't know how. Right. And so you'll want to be able to quickly host things. And yeah, just like Paul said, even for your portfolio, if you create a new project, you want others to be able to see it, you'll need to have that information there. So I would definitely suggest that. Okay. So why did I even bother telling you about the cloud other than I think the cloud is fascinating in the future? Well, because when things were on premise, like I said, it was expensive, right? It was expensive to have data. And even when cloud computing sort of started, it was really expensive to store stuff. Hence, we went into this. Oops. I guess I'm going to just do a share screen. I like this more. The other one is tripping me out. I'm so sorry. Then we went to this idea of, it's called ETL, which stands for extract, transform, load. ETL is extract, transform, load. And what that means is you would get some data from your user And based on what you were wanting to do, not always, your data is not always going to be perfect. And especially when we're dealing with non-relational databases or NoSQL databases, you might get some data, and we're going to see sort of the functionality and sort of the flexibility of it, but you might get some stuff that maybe isn't great data. Not everything comes perfect, right? Not everything comes where you have everything you need all the time. Data scientists will tell you that you got to clean data. You've got to make sure things are, X, Y, or Z. And so what would happen is when it was expensive, you would extract the data. So you'd get the data from whatever source, you'd ingest it. Then you would transform it. So you would clean the data and just get what you needed. And then you would load it, right? Because you're saying, hey, it's expensive for me to host this on my database. It's expensive. So I don't want to just waste money by just putting a whole bunch of junk on there, right? I want to make sure it's clean and it's concise. Now, what people would find though, is there was a trade-off because it was cheaper to do that. But down the line, if your company was adjusting and trying to do something new, you've got rid of all this data that maybe, if you wanted to see if there was a different user trend and you're like, it would have been really helpful if we would have had X data, but we got rid of it because we didn't think it was useful, because we didn't think that it was something we needed, and we got rid of it. And that's a bummer, right? And then that kind of realization, it was always a trade-off because things were too expensive. And so it's like, whatever, that's fine, we can adjust. But then as AWS came in, and as Amazon loves to do, is they undercut everybody, right? Made it really, really cheap. Once it started getting cheap, people said, well, why are we, if it's so, and right now data is like dirt cheap, right? For you to just hold data. And so then it went from an ETL to an ELT format. And that stands for extract, load, transform. And what that means is now companies will operate this way, to where they're going to extract the data and then they're going to throw it on the cloud. And then based on what you're wanting to do, they can manipulate it. You can have data scientists, or you can have AWS or Azure or GCP, kind of go through these processes to get whatever you want to do, right? But you're not losing out on data. You're not getting rid of it. You're not throwing it away per se. You are simply having this data, and you're having it like, if in a year you shift and you're like, oh, I need this data. Oh, great. I still have now 2 years of data to give us a better understanding of what our users are doing. And because data got cheap, we're able to extract, or we're able to do that because we're saving everything and not getting rid of stuff and then being like, oh man, in the future, I wish I would have had that. Right. And so that is this exact extract, load, transform. I'm going to make this bigger because we can have a lot more data, and it's still cheaper than back in the day when we used to have to transform it before and get rid of some stuff. Now, why is that important? Well, because there used to be, and this is kind of where we're melding into the databases, there used to be a, really the main one, or the main type, was what we call a SQL database. So you guys have probably dealt with this, where if you come from Python or Java, you've dealt with this for sure, right? And there's a lot of types of SQL database, which SQL just stands for structured query language, right? And this is structured data, and you're going to hear it as structured data. And the examples of this are going to be so I'm going to put EX. These are going to be your MySQLs. So MySQL, your Postgres, QL. And there's a couple of different types, but the whole point is they save data in a tabular way. So the way you can sort of think about it is, think about like an Excel doc or a Google Sheets, where you've got some sort of column, right? So let's just do this. Like, here's going to be my little example. And what you're going to do is you're going to have a whole bunch of columns, right? That this is going to be like first name, last name, Sorry, these aren't going to be straight. My bad. Or even. Just freehanded. I'm no Picasso. Oh, these are tough. Definitely not a Picasso. Okay. So you're going to have all these columns, which are all your different attributes. So it's your first name, your last name, your email, your password, your age, your address, whatever we're saving. And each row or entity is each entity is what we call a row, right? So this row represents one instance or one entity within my database. Now, the big thing with structured query language or SQL or tabular data is another way it's called, because it's all so tabular data is every row must have it's structured, right? And so every row must have a value for each column. Now it can be null or it can be an empty string, but it has to have a value for each column. It is structured, it is rigid, right? You must do that. And so each entity, though they might be different, each row must have a value for each column you have. So let's say like Seal, for example, only has the name Seal. But if you were to put them in a database, they'd have to have a value at last name. I don't even know if one name counts as a first name and last name. I don't know how that technically works, but they would have to have a value for whatever. So if you have a middle name, they'd have to have a value there. They'd have to have a value. It could be null. It could be something. It just can't be empty, right? If you say that it can't be empty, then it can be empty, right? You have to have something there. So if I were to go to Seal's profile and say first name, it would give me back null. That's sort of the structure. That's a good thing, right? That helps us have better data, but it's also quite limiting, right? Because let's say that it just can be kind of limiting and it's not super rigid, or it is super rigid and it's not flexible. Hence comes in our good old no SQL. So I'm going to bring this in, and this is going to be our no SQL. And no SQL actually stands for it's not SQL. It is not only SQL. Because you can still call, like, you can make a query. So again, if you were in Python or you were in Java, you made queries to this database, right? And you used SQL, you use the actual query language to say where, name, whatever, from users, get this attribute, and you just made these requests and it would basically go in and get all this data, right? Well, you can still have some of those queries, some of the no SQLs kind of databases to allow you to make queries like that, but not all of them, right? And so that's why it's not only, because there's other ways to get data. Now, again, what is no SQL? That some of those examples are going to be, oops, I don't want that. I want this guy. So some examples here are going to be MongoDB, which is what we're going to be using. Document DB. Now this is going off the screen. Let me grab it. We're going to have DynamoDB, CouchDB. There's other ones too. Like there's I believe Cockroach DB is another popular one. But there's lots of different types, and they all can vary, right, on their structure and how they're set up. But what the big flexibility is as we've transformed from, okay, we need to take in this data, it needs to be buttoned and it needs to be tight because it is expensive for us to have, to sort of, hey, I'll take anything you'll give me, right? Data is money. Think of why Google is free, because you are the product, right? Why is Facebook free? Because you are the product. It is the old additive. If there's something in tech that is free, that means that you yourself are the product, right? That is it, right? Like they're making money off of you. They're not giving you anything. Nothing in life is free, that whole thing. But that's really the truth, right? And so because of that, they want to get any sort of data that they can. And so by using something like a NoSQL database, it's also known and it can be known as like a semi-structured. Because we can and we will create what we call a schema, which is basically here's a blueprint of what can happen. But if there's different things that happen, I'm okay with that, right? I kind of want this stuff, and we can create validations to say, no, I do need a first name. I do need a last name. But if I get something else with this, if they say, hey, I have my PhD, so I want that added to my name. It's like, okay, great. Not everybody has a PhD. So some people will get that and some people will not, right? And we're good. We're super chill. This is like very type A, right? No, you must have X, Y, or Z. It's like the strict parent. And then like, you can sort of think of NoSQL as like the fun uncle, the fun aunt. It's kind of like, we could have ice cream for dinner. That's chill. If we want to have it for breakfast, that's also okay too, right? We will, as long as you're getting food, as long as we're getting data, does not matter. Now, there's other types too that I think are probably beyond of what I want to talk about that are not just what we're doing. So these are going to be, we're going to talk about this in class too, but the semi-structured data, the way that we're going to handle it is it is going to, it's going to be saved as documents, right? Because we're going to save it. Really, it's just a big, looks just like a big JSON file. Like it's just a big object. Where here in our structured query language, we know that everything's saved in a table, hence the tabular data. It's got tables and it's got columns and rows. Here is documents, which just gives us flexibility, just like an object in JavaScript can grow or shrink, same sort of thing. If you want to add in that you've got 18 names, whatever, like it's okay. It's the fun ant. It's like, yeah, whatever. We can just do whatever. You want to add gummy worms to your ice cream? That's fine. We can do that. Compared to here is like, no, you must have a vegetable, a meat, and a carb, which is how I was raised. Unfortunately, because ice cream rocks. But that is like very rigid of what you can and cannot have versus a NoSQL database allows us a little bit of flexibility. Now there's trade-offs for both, right? Because you've got a little bit more rigid and succinct data, it is a little bit easier sometimes to handle and manipulate that. You can make queries, you can join tables together. We don't have to do any of that with documents, but it makes it a little bit more challenging when we're trying to connect two entities together. Now, another key word that hopefully, if you guys again are coming from Python or Java, you've known this as a, what is it when two tables want to come together? What is that called?
Join.
A join. But what is if I've got a person who's associated with a pet, or if I have multiple pets, remember, does anybody remember what that was?
One-to-one and one-to-many.
Yeah, exactly. Relationships, right? So there was some sort of relationship between me and maybe one pet or multiple pets, or my pet could be in relationship to me or my wife, right? So I could have this many to many. And so you're also going to hear these be referred to as a relational database because we have these relationships. We have these foreign keys that we associate them with and these primary keys, and we can associate the two together. Non-SQL or not only SQL is what we call a non-relational. This is going to be the big, like, a big naming convention is non-relational. That doesn't exist here, right? We don't have any sort of one-to-many, many-to-many relationships. We can connect some things together in a unique way. Basically, just having that as a key value parent, like, oh yeah, this is associated to this. That's cool. But we don't have any sort of, okay, so this has to connect here, and we have this like ERD diagram. It is the Wild West, right? There's, and again, that's some of the beauty because it's so flexible, but it's a little bit more challenging whenever you're trying to relate multiple things together and you're trying to handle. Then when you get into, there's other types of like graph databases. That is like a CouchDB is that way, where it basically is just a node that looks at another node and it's like a big web that's connected, which is great. But then there's some issues with just how that expands and it can't decrease and things like that, which people can run into. So a lot of that to say is there's a lot of options that matter to your use case. the big things to take away is that whenever we are dealing with a non-relational database, we deal in documents and it's semi-structured. When we're dealing in relational databases, it is structured and it is tabular, or yeah, everything's in a table. Okay. Any questions? We got 5 minutes left. We're going to talk about this a little bit in class, but any questions on databases, the history and why we're moving towards non-relational databases or MongoDB or any of that? Did that make sense? Let me see chat. Sorry. Oh, there's a million things in chat. Any questions?
Yeah, I have I have one. If
Yeah.
you probably answered this already, but I was wondering, is there a reason why MongoDB versus the other ones?
MongoDB is pretty popular. It's also, like, I would say it's the easiest to sort of pick up and to understand. And it's a very, very, very popular database.
Okay.
And AWS, when you create a MongoDB cluster, it looks like document DB. Like that's just how it within AWS, if you instantiate a Mongo cluster, it is document DB. That's how they refer to it. So it still is a very, very popular DB. And then it's just what people have put together for this idea of MERN. Now, that is sometimes people put things together because it sounds good. Not that I love Mongo, so don't get me wrong, but you're not going to put like CERN and then have a structured database, right?
Yeah.
So sometimes they do that, but Mongo just is probably of all the non-relational databases, Mongo is definitely the most well known for sure.
Okay. So yeah. Okay, I get it. I appreciate it. Thanks.
Yeah, of course. Anything else? Any other questions? Now, I do want to note, MySQL is still wildly popular in the same way that Java, I'm not talking smack to anybody that learned Java. Java's outdated and old, but it's still legacy and people are using it. I don't mean outdated, like obviously it gets updated and people will be attacked if, some people heard that, but most people aren't going to a Java, right? Because there's no point in doing a Java when there's other things. There's a whole bunch of other tools that do other things, but fortunately for those, especially that took Java, is lots of companies, their entire code base is already based on that, and they're not going to re-switch it over to a new language unless it gave some crazy advancement that maybe isn't the case. It might not be as efficient or for a specific use case, but they're not going to just rewrite their entire code base, right? Or if they do something different, if a new product's coming, maybe it's written in Python or Rust or Go or whatever the language that they're needing. And I just say that of the same things operating with SQL and MySQL. I mean, though MongoDB is kind of like the new kid at school that, or even just non-relational databases that everybody's using because like, let's save all the data. Companies have still, like, their entire database is already in MySQL or Postgres or however it is. So there's still plenty of opportunities and it's still very, 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 very well used. So don't just think like, oh, I just learned MySQL and it's like basically a dinosaur and basically dead inside. It's not the case. It is still wildly used. So both are really, really popular. And that's why I love that you guys have the opportunity, if you did, to take both, because now you get an example or you get to kind of see how both operate. And if you didn't, that's very okay. You can go learn SQL pretty easily. It's not the most challenging once you get it. Or once you sort of start picking it up, it's not the most challenging. And so, but having a knowledge of both is really important, in my opinion.
Actually, I have another question.
Mhm.
Now that you're talking about different languages, and their usage. So I've come to realize that a lot of companies have proprietary languages. Like it's hard to learn it outside of the circle. within outside of the company. So how would you, as people who've been out there in the working space, like for example, Salesforce, they use a proprietary language called Apex. How would you learn that? Because if you don't even know how to, unless you find some, backroom guy, is like, hey, I got Apex for you, Brody. Hey, that'll be whatever. It's like, it's hard to find out, I guess. Udemy actually has it.
I'm looking right now. Yep.
Onboarding, I
Full
guess so.
stack development with Apex and Lightning. Become a Salesforce developer. Mhm. Yeah. So Udemy's got it. There's a lot of people who specialize in teaching these special languages too. So it's not just like if you know something, and I think that's what I said at the beginning, is like getting to know a tool. If you know it, you can then go teach people like yourself, right? Who want to go
Mhm.
learn. But yeah, Udemy's got, I'm looking at, there's a whole bunch of courses on it.
Yeah, it just seems like, yeah, I get it, but at the same time, it would seem like, yeah, if you would be bringing on a lot of people who are just learning or have recently learned your proprietary language. So
Sure.
you would have to rely on the people that have been with you since the very beginning.
So it looks like you can actually, I'm looking at, it's called Trailhead, and we're about to start class here. I'll put this in chat, but it looks like you can, looks like you can, they have, and this is where a lot of companies will do, is they'll just have their own training. So it looks like here's a training that you can do. There's a database intro on Apex and how it works. And you keep learning. And if you sign up, then you can keep learning. So yeah. Okay. I am going to stop the recording here. Great questions though, Podcast L. I'm gonna stop the recording here, and then I'm gonna run downstairs, just get my water bottle, and I'll be right back.